Today we're going to continue talking about polygons and how to group them and what attributes they have, but we're going to focus just on the quadrilaterals. So using the information we had yesterday, looking at which attributes are similar, that's how we're going to organize them together. So we're going to kind of create a circle or like a bubble organizer to put some inside of others. And then we're going to write some statements about them. So I'm going to draw a really large circle. And everything inside of this circle is going to be called a quadrilateral. So this is a really large group that has a lot of different polygons in it. Everything that has four sides will be considered a quadrilateral. So now as I get more specific, there's a group inside of quadrilaterals that have to be special because they have parallel sides. So I'm going to draw a smaller circle inside. So what is that polygon called that has two sets of parallel sides? So it has four sides, and then two of them, two sets are parallel. So this one's parallel to this one. This side is parallel to this side. So what that's called a parallelogram. So as I see, this parallelogram is inside of the quadrilateral. So that means that all four-sided figures, we have a lot of four-sided figures. Some of them are parallelograms. So if I am inside of parallelograms, yesterday in our chart, there was one of those polygons that was underneath of a parallelogram. Well, I have something that's called a parallelogram, but it's also special because it has special angles. It has right angles. So it is special because it has not only parallel sides, this side is parallel to this side is parallel to this side. So this rectangle is also a parallelogram, it's also a quadrilateral, but this one is special and it's called a rectangle. So I notice this rectangle circle is inside of the parallelogram. So that means a rectangle is also a parallelogram is also a quadrilateral, because this is inside all these other circles. So there's another one that's also a parallelogram. I'm going to draw it like this. I'm going to create a Venn diagram. And this one is not special because of its angles. This one's special because of its angles. This group over here is special because of its sides. All four sides are congruent. So this one is special because of its sides. It's called a rhombus. So all rhombuses are parallelograms. All rhombuses are quadrilaterals. So I have a Venn diagram. I have something that's a rhombus and a rectangle. It has both characteristics. It's special because of its angles, and it's special because of its sides. What is that one called? Well, maybe you guessed this already. It's special because of it has four right angles, and it's special because all four sides are the same. So a rhombus and a rectangle kind of put together. So kind of if we connect this to what we're talking about in science, if we have a parent, a mother that's a rectangle, a father that's a rhombus, and they put their traits together and they share them with their child, and that would make it a square. So I have space over here. Now yesterday when we were looking at our chart, we had two different quadrilaterals that didn't have a lot of the same highlighted attributes. They were different. So one of them is a kite. A kite is special because it has two sides that are equivalent, congruent to each other, and it has two other sides that are equivalent or congruent or equal to each other. So these two are equal and these two are equal, but it doesn't have parallel sides. It doesn't have all four sides equal. It doesn't have right angles, so it can't fit over here. It's different, but it's still a quadrilateral. So I can't include anything inside of a kite. There's nothing more special than these terms. So I'm going to draw a second circle that's all by itself, but it's inside the quadrilateral circle. It's in the quadrilateral family. So what's the one we haven't talked about yet? Right, a trapezoid. A trapezoid is not a parallelogram because it's not in that circle, and it only has one set of parallel sides, just one. I can draw them either way. It just has one set of parallel sides, so I can't say it's a parallelogram, so it has to be over here by itself. Okay, so now I'm going to look at if I can make some statements about this. I'm going to have to scroll up a little bit so you're not be able to see all of my diagram here to make some statements. So I could start off by saying, I'm going to pick a rhombus right. I'm going to pick a rhombus right here. I'm going to say all rhombus, when you make it plural, when you're talking about more than one, is actually called a rhombi. So I'm going to write that. All rhombi are also parallelograms. And what else? What other circle is it inside? Yes, a quadrilateral. All rhombi are also parallelograms and quadrilaterals. All rhombi are also parallelograms and they're quadrilaterals. So I can actually call it a polygon too, because everything we're talking about is polygons. So I could actually add that to my list if I wanted to. All right, so now comes these statements that say all of this polygon is this, but only some are the other. So let's look at an example. I'm going to look at a square. Squares are inside of this rectangle circle. So I'm going to say all squares are rectangles. All squares are rectangles because they're inside of it. Are all rectangles squares? That's how we say the other part. All rectangles are squares, but not all rectangles are squares. So let's look at this again. All squares are rectangles, but not all rectangles are squares, because see, only some of the rectangles fit in the square category. Squares are all inside the rectangle. So all rectangles, all squares can also be called rectangles because they all have 4 right angles. But not all rectangles are squares. So I'm going to set this up again, and I'm going to have you fill it in, and I'm going to check this tomorrow. All something are, I'm going to leave a blank because I'm going to have you pick an example, but not all blank are this. So let's look at the pattern I did. The first blank I picked was a bigger circle. My second blank was a smaller circle, and then I flipped it around. The smaller circle was not all part of the bigger circle, so I flipped it around. I actually, let me restate what I just said. Let's scratch what I just said. I picked the smaller circle and said all of these are part of the bigger circle, but not all the bigger circle are part of the smaller circle. So see if you can fill in, not using squares. You have to use something different than squares and rectangles together, that pattern. I already did that. You need to pick something different. Can you say something about trapezoids, kites, rhombi, parallelograms, and compare it to one of the others that are in here? I will check this statement tomorrow when you turn your math notes into me.